So we've actually done this sort of question a number of times in lecture, in group work, and there are videos, and you pass them for homework. So I hope by now, I've seen some of you, you're picking up on the general way of dealing with these. Let's work it out. So it's very hard to use these percentages as they're given. And this is true for doctors, lawyers, for lots of people. The way we deal with them in 101, and in fact the way that people deal with them in general who are trying to understand the meaning of these things, is to get rid of the percents and talk about total numbers of people. So you might start with 100,000 people. And the idea is that 0.5% of them will have this disorder. And 0.5% means multiplying by 0.005, right? And that's going to be 500. So 500 people have the illness. They don't know it, but they do. And then everyone else does not. So 99,500 do not have the illness. That's the first piece of information. Now, I've written the next piece of information a little differently than before. If you do go out and read newspapers and magazines, the way tests are described, whether it's colon cancer or prostate cancer or breast cancer or what have you, is there's some percentage of people who have the illness who get correct test result, and some percentage of people who don't have it who get an incorrect result. So we're told that 95% of people who have the disorder or the disease get the correct result. Well, 95% of 500 is 475. These are true positives. So this means they have the condition, and the test agrees. The test catches it. The test reports it. We're not going to worry about this branch. This would be false negatives. This is what people are generally scared about, is missing something. Over here we have lots of people that do not have the disorder. And we're told that this particular test, 3% of individuals who do not have the condition will also test positive. Using this information to a large degree involves labeling your numbers. So these people do not have the disease, so we know that 3% of them, 0.03, will test positive anyway. And notice how, even though it's a small percentage, because there are so many people that don't have it, you end up with lots of false positives. These are false positives. 2,985 people don't have it, but they're told they do, or that they might. And then over here would be true negatives. We're not worried about that at the moment. So the question says, you have tested positive. Crap. What is the probability that you actually have this condition? Well, if you test positive, you either have a false positive or a true positive. Well, there are 475 true positives, and there are 2,985 false positives. All said and done, that is 3,460 positives. Now, what are the odds that your positive is amongst the true positives? Well, 475 of those are true positives. The vast minority. If you calculate that, 475 divided by the answer, you'll get 0.137, etc., or about 13.7%. So not very likely. This is surprising. This should be surprising. 13% aren't any of the numbers here. Where does this number come from? Why is it so low? Why is a test that's 95% accurate only giving me 13.7% confidence in the result? Why is this the case? And this is common. This is if you look into the news, if you read magazines and newspapers, you will find this coming up. And it has to do with how rare the disease is. And here's a way to think about it. If you have a big bunch of people, lots and lots of people, and only a small number of those people have some illness, it could be a rare illness. And this bunch of people could be a low-risk group, say for HIV, or it could be young women who statistically have no benefit in mammography, for example, or any other low-risk group. So you have a small group that might be ill and a large number of people. Well, a very accurate test will catch almost all of the ills. That's great. That's good news. They're diagnosed. They can be treated, hopefully. However, a small percentage of healthy individuals will be diagnosed as well. False positives. So even though a test may have a 1% error, 1% of a very big number might be more people than are sick at all. If you go back to our earlier example, there are only 500 who have the illness, but we have almost 3,000 false positives. We're getting more false positives than we expect people to have the condition anyway. So, how do you get your head around this? I recommend, oops, sorry for the camera moving there, redo the problem using 50% instead of 0.5%, and you'll end up with something like 97%. If the condition is very common, if half of the population has it, then most of the people who have it get a true positive. And a smaller chunk of people, it's the same percentage, but the same percentage of a smaller population gives you less people, maybe half as many or something. You get less false positives, and then the likelihood that you can be confident in your test result increases greatly. So try to redo the problem with this and compare. See if you can spot how important the incidence rate is to the percentages.